as I said, we're going to start solving quadratic functions. The first way I'm going to teach you to solve is by graphing, okay? And it's probably a good thing I start with graphing, because when I teach you the other ways of solving quadratic functions, you're going to have a real appreciation for the algebraic ways, because graphing is so much more work, actually. But we already know how to graph, so we start out with by learning how to solve them by graphing. So the first thing we're going to do is fill in the steps here. How do we solve by graphing? Write the equation in standard form, ax squared plus bx plus c, but we're going to set it equal to 0. Okay? So in other words, there's not going to be a y all the time. In fact, usually there isn't. But if there is, the y and the 0 will be interchangeable. Okay? And then we're going to graph the related function. In other words, as if it were y. So we're going to take, we're going to step back and say, okay, well, what if, we replace our 0 with y, and we graph it now, because we know to be able to graph it, we need x, y pairs, we need ordered pairs. And then we're going to determine the zeros of the graph, which we've already talked about. We've already learned how to identify the zeros of the graph. The zeros are the x values, where the y values equal 0. And we're going to say these are the solutions. So I want you to, right here, I want you to circle this. The zeros, solutions. In other words, those words are interchangeable. Remember I said that word zeros, when we learn them, it's going to play there's going to be lots of different things we can say about those. Right now we are connecting the zeros to the solutions of a quadratic function. Okay, so let's solve x squared plus 2x equals 3 by graphing. First thing we need to do is get it in standard form, set equal to 0. So what would we do to this one to get it in standard form, set equal to 0? Cody?
Subtract the 3 on both sides.
Yeah, we'd subtract the 3 on both sides. And we would have x squared plus 2x minus 3, and we'd have a 0 on that right side. So step A says get it set equal to 0, first of all, okay? Step B said now write it in the form of y equals x squared plus bx plus c. So we're going to say, oh, okay, well then our equation that we're going to graph is y equals x squared plus 2x minus 3. There's our equation we need to graph to help us find the solutions known as the zeros. So, to be able to do the graphing, we identify our A, B, and C. A is
1.
Class B is 2. C is
-3.
-3. So, I want you to join in with Cody, okay? He's part of the class and you're part of the class, right? Okay. First thing we did when we were graphing was we found the vertex. Anybody remember how we start finding the vertex? What do we have to do for that? Maybe you want to get out your graphing notes. If you think those are going to help you, because you're going to need to be able to graph again. Cody?
Is x equals the opposite of negative b over 2 times a?
Yeah, we start with that little formula. This is how this starts. Remember, that's how we started. We get the axis of symmetry, which then, if we get the axis of symmetry, that tells you what the x value of our vertex is supposed to be. So we're going to substitute in. For B, we'll put in a 2. For A, we have to put in our 1. Now, we're going to be using up all kinds of space here, so don't get too carried away writing in 60 font on your notes here today, because we got lots of stuff to do on this. So we have x equals -2 over 2. What is x equal for our vertex?
-1.
-1. Okay. So you know what? I'm going to right now, I'm going to give you those rulers that you're going to draw that axis of symmetry before we even move on. This is a vertical line, the axis of symmetry. We're going to go put a dashed line on our graphs at x equals -1. That means the vertex better land on that, right? So the next thing we need to do is we need to go and find the y value of our vertex. Let's move to the side over here and let's find y of our vertex. So we have our y equals, we're going to substitute into our y equals x squared plus 2x, subtract 3. We found out that the x value of the vertex is -1, so -1 in parentheses squared plus 2 times -1 and subtract 3. Go ahead and find the y value. Keep going and get that for us. Here's the y value of our vertex. Okay, I get that our vertex should be -1, -4. So go plot your vertex on your axis of symmetry. If it doesn't have line on the axis of symmetry, one of them is in the wrong spot. So that was our first point. That's like our first point. Remember, we need how many points? 5. Okay. So our second point is the y-intercept. Well, remember the shortcut to finding the y-intercept?
It's the C.
It's the c value, isn't it? So since c equals -3, that means our y-intercept is what? 0, -3. 0, -3. So there's our second point. So we go to 0, -3 on our graph and plot a point. What do we do with that point? Reflect it. So we reflect it over the axis of symmetry. So we should end up at -2, -3. Okay. And now we need another point. Where does that next point come from? So our third point was really our reflection, wasn't it? Reflection, reflect, 0, -3. And after we get done reflecting it, this is where it should be on our graph. But now we need a fourth point. Where do we get that from? We pick an x value. We pick an x value that hasn't been used. Which x values have been used already? -2, -1, and 0. They've all been used. We can't use those again. So what x value could we use? +1? Could we use that one? Okay, so let's do when x equals 1. So we have our y equals x squared plus 2x minus 3 that we're going to substitute 1 in for. So what ordered pair did we just find? 1, 0. There's our fourth point. So we'll go to our graph, and at 1, 0, we'll plot a point. And point number 5 comes from where? Yeah, we reflect that one. So we're going to reflect 1, 0. And what do we get? We're over on the other side. So we're 2 away. So we have to go 2 away on the other side. So we're at -3, 0. Now, we're not done with this problem. We're not just graphing today, what are we doing?
Finding the zeros.
We're finding the zeros, we're solving by graphing. So the solution or the solutions to this quadratic function are the x values where the parabola crosses the x-axis. So in other words, it's the zeros of the function. So we would say that, we would go, let's go up under here under our graph and let's say the zeros are, what are they? -3. Is there only one of them? And 1. Well, if that's what the zeros are, guess what? That's what the solutions are then. Solutions to this are x equals -3 and x equals 1. If you were asked to solve this quadratic function, that means you need to find some x values that make basically what you're finding are the x values that make the equation equal 0. Those are considered the solutions. So now we're going to check though, because that's what we always did with our zeros, remember? We're going to put our -3 in. So we have our y equals x squared plus 2x minus 3. We're going to put y equals -3. We're going to substitute -3 in first and see if it checks out. And how will it check out if we get 0 for y? How do you feel? Do we really need to check 1?
No.
Why not?
We've already used it.
Because it was one of our points that was one of our points we found with algebra already, didn't we? So it's kind of seems like if we go and check 1, then it's really going to look just like what we did over here, isn't it? Because that's what we did for our 4th point. So there's really our check for the other one. Okay. Okay. So this is somewhere on here, it better show that this is what we just did. We just solved that quadratic function. There are its solutions. Make that very clear on your paper. How do you come? You have so much white space around here. Amazing how you can cram that all in and make it look like. What did you write down the y-intercept thing? The second and the third point. Where did you write that down? Where did you write it down? You just grab them. So like here, this part right here. Right here. Where
Yeah,
did
it's
you,
underneath the ball.
it is underneath or something? Okay. Anybody have any questions on this one before we try the next one? Okay, anybody need this here any longer? Okay, let's go in the back. We got a couple to do back there. Let's start with number 2, solve x squared equals 9 by graphing. Okay. What's our first thing we do? Get it set equal to 0. Yep, so we're going to subtract what? 9. So we'll subtract 9 so that we have the quadratic function in standard form on one side and 0 on the other. Okay, and then how do we start step B? Pardon? Don't we have to set it equal to y instead of 0? So the 0 and the y just, they exchange. 0 is y, y is 0. Okay. What's our a value? 1. B? 0. C? -9. What do we already know about the vertex for this one? What do we already know about the vertex for this one? Do we do we have to go through that long process of finding the vertex? Why not? B is 0, so that means the vertex is the y-intercept. Are you with us over there, Tori? Like, kind of, you get Mrs. Allen back there, so I just want you to know you're not alone. Okay. So the vertex is also the y-intercept because B is equal to 0. So this is, this is our clue right here that we can just write the vertex down right now. It is what? 0, -9. Okay? So with your ruler, where's your axis of symmetry going to be at?
0.
It's really the y-axis, isn't it? Remember? It's really the y-axis. So you're going to take your ruler and try and make it look like you can tell that this is the axis of symmetry, this this y-axis. And then you're going to go plot your point 0, -9, excuse me, on it. Do we reflect that one?
No.
No, it's on the axis of symmetry. It can't be reflected, can it? So now what do we do? Now we got to pick our own, and this time we got to pick 2 of them, don't we? We'll pick one, we'll find it, we'll reflect it. We'll pick another one, we'll find it, we'll reflect it. Okay, the only x value that's been used is what? 0. So this was our first point right here. So now we're going to find our second point, and what should we pick for x?
2.
2? 1? 1? Okay. I guess we'll go with the easier one. So we have y equals x squared minus 9. We'll substitute 1 in. I see why Cody wanted to pick 2. That one's pretty close to it, isn't it, Cody? Okay, so we're going to go with 1, and I get -8. Do you agree with me? Or aren't you there yet? And then we're going to reflect that. So our third point is the reflection of that. So it goes across and it reflects over to the other side. So that one is what? -1, -8. Okay. Okay, now a fourth point. What do you want to choose? 2? Okay, so when x equals 2, so we'll go here and do our fourth point when x equals 2. So y equals x squared minus 9. So 2, -5, that's what I got. That one gets reflected to -2, -5. And we draw our parabola. Did I draw my parabola last time either? I didn't, did I? Did you? Yeah, okay, good, because we should, yeah. I don't even remember doing it, so I must not have. Okay. This is what's going to be kind of important that we get a little bit better at drawing parabolas, because now we're using them to solve. We got to be able to tell where we think it is crossing the x-axis, or in other words, what do we think the 0 or zeros are. So, is it crossing in one spot or 2? 2, so we have zeros. So the zeros are what? What do you think? You got to estimate at this point. -2 and 2. But our points that have -2 are all right here. Can we, remember I had some people who thought they could do this. Can we have any points above and below each other in a parabola? No. So we can't have -2 and 2. They already have a y value that's not 0. We're looking for the y values, ones where y's are 0. Cody?
-3 and 3.
So you think it's -3 and 3. Well, those aren't used up yet, so we're going to take the chance, yes, sir?
I know this because I actually used those. I didn't use one, I used two.
Oh, so that's what happened. Okay. So right now we are thinking that the solutions are -3 and 3. But for us to do that, so basically we're saying we think the solutions are x equals -3 and x equals +3. But we definitely, unless you're Cody, Cody has to only do one check problem because he used +3 as your second x value. So he only has to check -3. Bless you. He only has to check -3 out. We got to check them both out because we didn't use 3 or -3. So we're going to check, and we got to do it with both of them. So y equals, I'll start with the -3. One checks out, for me anyway. And so the other one appears. So if we don't really legitimately give 0, we don't get to stop and say, okay, well, so what, that's where it looks like it's crossing out, I'm going to say that's what the solutions are. Then you got to try maybe something else. Maybe you got to try 4 and -4. You got to try until you get the y values that actually equal 0. Because that's why I was sometimes saying to you guys when you were drawing your parabolas, they were looking too much like this, too U-shaped. I mean, too square U-shaped. They didn't branch out like they should. And so we got to make sure we're not just drawing. Once we go through our points, we don't go just like this, vertically up. They got to be branching out. Okay, so you'll get better graphs that way. Anybody get questions on this one? Okay, so let's try one more. Solve x squared minus 2x plus 1 equals 0. Do we need to do step A? No. So it's already set equal to 0, so we can move right to step B, which says, what do we do with it? What?
Put it in the standard form.
Is it in standard form?
Or we'll change it to, or
Get.
Change the 0 to y.
Good job. Y equals x squared minus 2x plus 1. A equals, B equals, C equals. Okay. Can we shortcut our vertex this time? Why not?
because your B is in 0.
B is in 0. Okay, so we have to do our, so number 1, we're finding the vertex, right? That's what we're up to. We're going to do x equals the opposite of -2 over 2 times 1. You know what, I think today I'm going to be different. I'm going to do the opposite of, I'm going to give the opposite sign to the top, and I'm going to make that a +2. And I'm going to say that x equals 1. And now, I'm going to go find my y value.
You have to put the axis of symmetry.
Oh, you're right. Thank you, Cody. Way to stay on top of it. X equals 1. Now I will go and find my y.
Aren't you supposed to find what out of 0 or 1 for C?
For what?
For C. Aren't you supposed to put 0, 1?
Oh, I'm not to that point yet. I'm not ready to find my y-intercept yet. I'm still trying to find the vertex. Are you done with the vertex? No? Okay, so right now, what I'm doing now is I'm taking my 1 that X is, because it has to be 1 for the vertex, and I put it in and I'm getting my Y value. So right now I'm finally at the point of being able to say that the vertex is 1, 0. You guys agree with me? The vertex is 1, 0.
Yes.
Okay. So we'll put a point on the axis of symmetry at 1, 0. Now we're ready to move on to our second point, and that is going to be the y-intercept, which is the c value, right? So our y-intercept is what? 0, 1. I'm going to go put that point on. And I'm going to do what with it? Reflect it. So that one's going to, reflect 0, 1, and that, I should just say reflect the y-intercept probably. So that becomes right over here, which is 0, which is what? Oh, wait a minute, I just did it wrong. Thank you, I did, yeah, that's very easy to do. And you guys, I saw that on the quiz you took, that happens very easily. I need to reflect over the axis of symmetry, don't I? So it needs to go over here. So my new point for that one is ordered pair what? 2, 1. So the reflection points always have the same y values. They have different x values. Okay, now, this is one time when we're solving by graphing. I'm going to let you out of the 4th and 5th point here. Why do you think I can let you out of the 4th and 5th point? Why do you think? Cody, I'm not going to let you answer. They got to think. Why? But thank you. Why do you think I can say, you know what? I think we can be done because we're solving by graphing. We actually have enough to start our U here. In fact, let's just do it. You know what? Let's just say, you know what? It's going to go something like this. Michaela, why do you think we can quit? You already have the 0, right? How many zeros are there? 1. The vertex is our 0, isn't it? It's sitting on the x-axis. So we already know that the 0, so I'm going to let you stop here because we're going to say the 0 is what? 1. So that means our solution is what? X equals 1. Okay, how do you feel about this? Do we need to do a check roll? Why not? Because that's the x value of our vertex, which we've already put in to get our y value, and what did we get for y?
0.
We got 0, so we're feeling fairly confident about this at this point anyway. Okay? So, sometimes we can, you're going to have to decide when can you get out of certain things. So, I'm not going to say to you, every single one of them has to have 5 points. Every single one of them has to have, if there's 2 solutions, 2 check problems, you make a good call according to like what we just did in our notes, okay? Anybody have any questions that you're not sure about? Okay, then I will get your homework out to you.